This is a quick talk that I put together, as Matt mentioned, on Action Cable and starting to move towards real-time web experiences in Rails. So what we're going to cover is a quick rundown of why you would bother to invest in learning about and using WebSockets. We'll then go into a quick overview of Action Cable and sort of the key pieces of functionality that it provides. We'll have a quick look through a demo implementation and step through some gotchas, good to knows, other B-sides and rarities and so on. So who am I? I am David Smith. I'm Sydney-based. I'm employed as a solution architect, but the views presented here are my own. I am a repressed full-stack developer and general web technology enthusiast. I love prototyping. I love playing around with different integration architectures and finding the best ways to use fabulous technologies. I do not generally tweet, but I am on Slack on Ruby Australia at David Smith. So a quick history lesson, first of all. This is a diagram that no doubt you are all familiar with. It is the traditional request response cycle. Since the dawn of time, this is how websites have more or less been built. A client wants some information, so they make a request. So it might be an HTML page, it might be some other kind of document. The server will build the request based on what it knows at the time, and it will send that response back to the client. So some observations about this model. First of all, it's initiated by the client. The client is in control. Each request is stateless. They're all independent from one another. Data is gathered at a point in time, which is when the client has requested that information, and it's relatively heavy. We'll go into that in a moment. Generally, this is well suited to browsing, and I'm not quite sure why I put browsing in scare quotes, but you know, here we are. So if we wanted to start to move beyond this model of document browsing, there's a whole bunch of use cases that are now pretty common in the web, I guess. So basically, when you've got information that might be changing really rapidly, or it might be changing sporadically, it might be changing not at the request of the client. So you would want to get information out to a user. So some of the common use cases here are things like, you know, monitoring dashboards, live events, stock tickers, chat and messaging is a really typical use case. Alerts, push notifications. I'm sure you're all getting more notifications than you can handle these days. And collaborative type interfaces and use cases. So think Google Docs, you know, showing the appearance of other users up in the corner and watching their text appear as they type. So I'm going to have a quick skim through some strategies that we can use to start building these kind of features on top of HTTP. The traditional way to do this was polling, which I'm sure you've all used at some point. Basically, the client repeats their request every X seconds, and the server will respond whether or not there is new data available to send to the client. This sort of works. It has some drawbacks, being that at worst case, you can be waiting up to X seconds to get new data. On the other hand, if you want to trim down X, you can be sending a lot of blank requests back and forth, and it puts unnecessary load on your server. There is a variation to polling called long polling, where the client will send the request to the server with a long TTL, and the server will hold that request until there is new information available to send back. This is a better model. It's a lot less wasteful. It can result in fewer empty requests and more up-to-date data. Still has some drawbacks. So, for example, if your data is changing very frequently, you can still be sending a whole lot of HTTP requests back and forth. Server sent events is is a technology that I don't fully understand, but the premise of it is that the client will open a connection to the server, and the server is then able to hold on to that connection and continually send new information back to the client as it's available. It again has some limitations. For example, I think the most connections you can have between a client and server pair is 6, and that includes all tabs that you might have open to a particular site. So that brings us to our silver bullet, our panacea of real-time communication on the web, which is WebSockets. So WebSockets works by using an HTTP, a handshake that's built on top of regular HTTP to upgrade the request to a WebSocket connection. And from that point, the connection stays open between the client and server, and enables what we call full duplex, so bidirectional and persistent communication between the two. This is not new. It's been around for quite a few years now. It's supported in all modern browsers, and by all reports, it can be quite useful. So let's have a look at what that might look like in practice. So there is a nice JavaScript browser API that lets you open a WebSocket connection to your local server and register some callbacks to respond on the client when new information is available. There's a couple of key points on the request itself. So the request will include this initial header to upgrade the request from an HTTP request to a WebSocket request. The server will respond accordingly with a 101 to indicate the protocol has switched to WebSockets. And from that point, assuming everything's configured correctly, you'll have a persistent connection. So this is what things look like from the client's point of view, but I guess that's not going to get you very far unless you have a server that is also going to support WebSockets and can send data out as it becomes available. So let's have a look at what that might look like. Now that brings us to Action Cable. Now the first thing I want to say about Action Cable is that it is not just WebSockets. Basically, it is, in addition to having WebSockets that allows us to communicate between the client and the server, we get some really nice abstractions around a pub sub model, so publish and subscribe model, in Rails itself. So for example, we have a connection. A connection can have many channels. The channels facilitate communication from a bunch of producers. So a producer might be a chat channel that is producing chat messages. The consumer is subscribed to that chat channel so that it will be notified of the new messages that are coming through. So that is some new terminology, I guess. So I'm going to step through each of those concepts one by one to have a look at a practical example of what that really looks like in Rails. So we start with the connection. Now the connection really establishes the communication between the consumer and the server. In a typical Action Cable app, you probably have one class of a connection. Your connection will need to be identified by something so that it knows basically who is being sent the messages that it knows about. It's a great place to do some initial authentication. So this connect callback here will check that that the user that you're logged in as should actually be able to access this particular channel. And I've just put a note here to probably do some real authentication if you're going to use this in production. So next we have our channels. Now our channels really form the heart of an Action Cable implementation. Conceptually it's somewhat similar to a controller, but it groups your streaming logic that is going to and from the between the consumer and your producers. The channel is long-lived, which is a is different to how we probably think about most Rails development, which lives purely within the context of a request. So the channel has some callbacks here, so some hooks. So for example, we have this subscribed hook, excuse me, in which we set up a stream from this named channel here called all notifications. We have methods that are available to us, like broadcast, which will send a message out to all channels, to all instances of the channel that are subscribed to that notification. In this example, this is very rudimentary, but I'm sending out a broadcast to that channel to indicate that the current user has just joined the channel. And importantly, the current user is not defined here, it's defined on the connection. But the channel has access to that information. Unsubscribed is another hook where you might do any cleanup, close off any handles or connections that you don't need when the channel closes. This method typing is not a standard callback. This is a custom action that I've defined on the channel, and we'll see how that's invoked in a minute. But basically, the demo here is supposed to indicate that I'm a user. I'm logged in, and I am doing a Slack style. David is typing a message. So the subscription is what lives on the other side of this connection. The subscription is the JavaScript implementation on your consumer. Your consumer is creating a subscription to the notifications channel that we defined in the previous slide. Again, it's got some callbacks. So when it's connected, it's doing some setups, some event listeners, and so on. This received hook will get invoked on every message that is sent back from the channel to the consumer. In this case, I've put a stub implementation that will take the received message and do something. It's obviously very dependent on your front end implementation. If you were using jQuery, you might do some DOM manipulation here, as opposed to if you're using something more advanced, you might be dispatching an action or modifying a store. Now, I mentioned that we would get back to this typing hook. So typing is a method that I've again defined on the client side. We have this method called this.perform, which will invoke the method passed as a parameter on the client. So it's basically it's RPC style method invocation. So from your client, you're able to invoke any custom method that contains any logic that you want to get executed on the server. Okay, so stream for is worth a call out. Previously, we were using stream from, which subscribes to any named broadcasting channel. Stream for has a slightly different usage style. So in this case, I'm listening to a stream for a specific post. So that's kind of hashing the post that I've passed in and using that as the subscription channel. So the use case here would be if I was wanting to get notified about changes or comments on a particular post, as opposed to notifications about all posts, I would use stream for as opposed to just the regular stream from. To send to a stream for named channel like that, you invoke this broadcast to method on the specific channel. And typically, probably the best way to do that is from a background job, or you might do it from a controller action after you've either updated a post or added a comment or similar. I will point out while we're here that these messages that are being sent across these channels are basically they're purely ephemeral. They aren't durable. The messages aren't stored in a queue or in a database or anything like that. The message will be distributed to any consumer who is connected at the time that the message is sent. So just, again, it's a slight difference from our regular request response model, and bears some thinking about when you're designing your channels. Adapter is a hugely important piece of action cables. So as your app starts to scale, you might have a whole number of clients who might be connected across a bunch of different action cable servers. And if we didn't have the adapter, the clients who were connected across those different servers wouldn't have any way of receiving messages that were sent to a server that they weren't connected to. So the adapter implements pub/sub across multiple workers or servers. Out of the box, action cable comes with a few adapters. The async adapter is the default one, which is not recommended for production use. There is a Redis adapter that is probably the most commonly used, that's backed with Redis pub/sub. There's also a Postgres adapter that comes out of the box. I don't have any specific experience with that Postgres adapter, but I understand it uses PG Listen under the hood to distribute those messages across your different instances. Now, I'm sure you've been wondering how I could write all this code without writing any tests, but you'll be thankful to know that testing is a first-class citizen for Action Cable. There are mature testing libraries available in test case and RSpec flavors, and a handy little guide on Rails guides about how you might go about testing your channels in particular. So at this point, I might pause for a second and have a look at a little demo which I've prepared earlier. This is essentially the code that I've just run us through here. This is our notifications channel. So I'll boot up the server. I've implemented a really basic session controller here that doesn't do any real authentication, but gets the point across. So our cable request here, as we said before, has switched protocols to become a WebSocket request, and from that point on, there are messages that are being sent back and forth. You'll notice that there's a handy little ping message that Rails implements itself as a heartbeat to make sure that the connection stays open, or to reconnect if it drops. I'm going to connect from another client here. I'm going to be a cat on this client. I've logged in, and straight away you can see in the log here that somebody else has joined. And then if I was to start typing a message, you get these updates straight away to indicate that this user is currently typing a message. So that is as far as this demo implementation's gone, but I think it kind of demonstrates that with not a whole bunch of code, you get some nice real-time features happening straight away. So back to, oops, just 1 second, sorry. So back to our slides. So I wanted to call this out specifically. I've mentioned it a couple of times along the way. Managing a persistent connection comes with a whole bunch of considerations that we may or may not think about when we're building a web app that's based around request and response. For one thing, the connection and the channels are long-lived. And when I say long-lived, that can be as long as a client has their connection open for, which could be days and endless, really, depending on your uptime. So obviously, don't do anything that's going to leak memory over time, or check that if data is getting out of date, for example, you might need to implement some kind of refresh mechanism. You really need to think about your deployments when you deploy Action Cable, because because those connections are long-lived, you could, if you're waiting for traffic to fall away from your existing servers, you might actually never see that happen. So you can potentially have old servers that are running an old code base for a long time and still subscribing to messages that are being produced from a producer who's on a new version of your code base. So have a think about things like how your message is essentially an API at that point. So have a think about how you're structuring your messages so that that's going to work for you. You need to have a reverse proxy and or load balancer that is that's going to support a long-lived WebSockets connection. And I've linked this excellent talk here by a guy from Netflix who was not specifically using Action Cable, but goes through a really awesome reference architecture about how they implemented scaling up their push notifications up to tens of thousands, up to bordering on millions of users at a time, which is pretty impressive. So just a couple of other good to know points. The great thing, I guess, about Action Cable is that it's using your existing authentication and domain logic. It's got some nice quality of life features like automatic reconnection if your client drops periodically. It's got a flexible deployment server model, so you can either run Action Cable as part of your regular web server, or you can deploy independent Action Cable workers if you want to be able to scale it independently. And the Redis pub sub adapter that's included really lets you achieve a fair bit more scale than you would be able to otherwise. So some gotchas or at least things to be aware of are that your messages aren't durable. They're not guaranteed to be ordered, nor are they guaranteed to be delivered. They're not versioned, as I said. So if your event distribution is forming a sort of a de facto API, just have a think about what sort of mechanisms need to be in place to support that. And as it stands, the client is JavaScript specific. So, for example, if you had a native mobile client, you would probably be best served to go and have a look for a native port of the Action Cable client, or consider what your other options would be. So just a few references here, for some from DHH himself. Michael Hartle has a really great paid tutorial on Action Cable, but the base documentation is itself very, very good for learning more about Action Cable. So in summary, that was a bit of a whirlwind tour of Action Cable and pub sub programming on Rails. We had a look at some of the build and deployment considerations. Overall, it's a really nice abstraction for building pub sub enabled applications in Rails. But I will point out that most people that I speak to who are Rails devs tend to not have used Action Cable a whole lot in production. So part of my hope for this talk is that we're sort of spreading the good word and encouraging people to make a bit more use of this in real-time web applications. If you've got any questions, comments, complaints, feel free to raise them now or hit me on Slack on Ruby Australia. And thank you, Matt. Thanks for organising.
Ooh, thanks, David. That was great. Yeah, I for one have not. It's all the people I've talked to as well is like, oh yeah, Action Cable exists, but have never really used it. And it's one of those things that I keep thinking, yeah, I should really try it, but it just never happens. But that was really good. Thank you for that. Does anyone have any questions for David?
No, all good. All answered.
All
Everything's
answered.
been
There you
covered
go.
so far.
Yeah,
Fantastic.
they're implementing it as we speak. The infrastructure is being deployed. So I assume you use this in production at the moment, do you, or not this, but you're using Action Cable in production somewhere? Or?
I have used it not in my primary vocation, but in a couple of other side apps that we've built at work. We've used Action Cable just for some really basic sort of engagement features, I guess you would call them,
Sure.
starting to, for example, show when other users might be editing the same page that you're on, and basic site-wide notifications and that kind of thing.
Yeah, cool. We came across a problem just recently that I thought, it'd be nice to be able to use Action Cable, but I have absolutely no idea how to implement it. And like going from not having any Action Cable at all, no infrastructure set up for it, to using Action Cable feels like there's at least a little bit of a hurdle there. It's not just a drop in place thing, but
yeah, there are definitely some infrastructure considerations, but yeah, I guess the Rails side of things is actually pretty tidy and is a pretty nice abstraction.
Yeah, it's just it's the everything else bit that you have to get. Yeah, like the scaling and managing connections and stuff. So
yeah,
cool.
This is true. Awesome. Well, thanks everybody. Appreciate it.
Thanks for